chemical and ionic equations. Hi, I'm Aneta, and today we're going to practice some past paper questions on chemical and ionic equations. So this is the first question I found. It says iron trioxide and carbon monoxide react to give iron and carbon dioxide. Give the equation for this reaction. So the first thing we know is that iron oxide is Fe2O3. So we can write that down. It then says that we add in carbon monoxide. Carbon monoxide is CO, so that's what we know as well. And then they both react to give iron, for which symbol is Fe, and carbon dioxide, which I know you know about. Then we can straight away see it's not balanced because there's two ions there and one ion here. So for this equation to be complete, we have to balance it out. So we can write Fe, O, and C because these are the three elements present on the left-hand side, and Fe, O, C because these are the ones that are present on this side. They should be all the same. So there's two ions, 4 oxygens, 3 and 4, and 1 carbon. And on this side we've got 1 ion, 2 oxygens, and 1 carbon. So let's focus on the ions first. There are 2 ions there and only 1 ion here. So we basically just put 2. So we've got 2 ions on either side. Then we've got 4 oxygens on this side and 2 oxygens on this side. So we know that there has to be more oxygens present on this side. We can practice to just write 2, do some scribbles with pencil, some pen. Then we've got 4 oxygens on here, but 2 carbons. So if we put 2 there, we've got 2 carbons. But now we've got 5 oxygens, so this is not something we could do to be balanced. So we can practice with that number, 3. We've got 3 carbons, 6 oxygens. So to balance it out, we've got to have 3 carbons on this side as well. We've got 3 oxygens and 3 oxygens, which give us 6 as well. So at the end, we've got 2 ions, 6 oxygens, and 3 carbons. And on this side, we've got 2 ions, 6 oxygens, and 3 carbons. So this equation is now balanced. This next question also asks us to balance the following equation. So we use the same technique. If you want to see the steps I do every time to balance an equation, you can visit my blog, for which I'll leave the link down in the description box. But now let's do the question. So we write out all the elements on either side. Oxygen, and how many there are. So let's do it then. Counting. How many coppers we have on this side? 4. How many ions we've got on this side? 4 as well. Sulfurs, 2 times 4, 8. And oxygens, we've got 2. Now on this side, we've got 1 copper, 2, 3 ions, 1 sulfur, and 3, 4, 5, 6 oxygens. So now we just gotta put some numbers in and try to make it balance. So the first thing we can do is that there's 4 coppers on this side and copper is on its own here. So we can just put the 4 down and that will give us 4 coppers on either side. Next thing we can do, there is 4 ions on this side. There are 3 ions on that side. So if we put 2 and 3 there, got 2 ions, plus 2 ions is 4 ions, the same as on that side. Next thing, sulfur. We've got 8 sulfurs there. Sulfur is only present here, so you had to put 8 sulfurs. Now the only thing that's left is oxygen. So we got 6 oxygens. We had 6 oxygens on this side, but now we added some more, so we got 16, 17, 18, 19, 20, 21 oxygens, and we only got 2 oxygens on this side, so we can write 10 and a half. And we get 21 oxygens on either side. This time, when we worked out the last number, it all fitted into the equation, but sometimes you have to move around the numbers and try different numbers before you get to the answer. So, at the end, we've got 4 coppers, 4 ions, 8 sulfurs, 21 oxygens, and we've got 4 coppers, 4 ions, 8 sulfurs, and 21 oxygens. We've got another balancing equation. In the exam, these type of questions are usually one markers. So if you don't get it, or you can't just can't find a number that will fit into the equation, just move on. It's only 1 mark, and at the end of the exam, if you still have time, you can go back and try some more. But if you don't worry. So again, we just write the elements present in the equation on either side of the equation. Then you count how many there are. So 1, 5, 2, 1. And then we've got 1, 1, 4, and 4. Of course, you can only put the big numbers in front. You can't just change these small numbers or add them whatever you want, because that would just change the structure of the substance and the equation would not be right anymore. So we've got 1 phosphorus on either side. We've got 5 chlorines here, but only 1 chlorine there. Chlorine is there, so you can just put the 5 down, and if it's wrong at the end, we can just scribble it out and put a different number. We've got 5 chlorines and 5 chlorines. Now we've got 8 hydrogens on this side and 2 hydrogens on this side. So what we can do is just put the 4 here. We've got 8 hydrogens on either side now. And now we just got to check the oxygens if they match. So we got 4 oxygens on this side, and we haven't done anything to this substance, so there's still 4 oxygens on this side. So the question is finished. Our next question says, bromine is produced commercially from the bromide ions in seawater by reaction with chlorine. Give the ionic equation for this reaction. So we basically just write down what we already know. So we know that bromine is produced, so Br and the little 2, because they always go in pairs. We also know that it's produced from bromide ions, so we've got Br minus. But we also know it reacts with chlorine. Chlorine also always goes in pairs. And now the only thing we have to write down is the chlorine ions that are left. Now we've got to balance it out. We've got 2 bromines on this side, so we have to have 2 on this side. We've got 2 chlorines on this side because it goes in pairs, so we have to have 2 chlorine ions on this side. And that's the question finished. Okay, so now we move on to the more difficult questions, and the most difficult from this unit. Write an ionic equation for the reaction that occurs when aqueous barium chloride is added to a solution containing sulfate ions. So we know what we know, we write what we know already. So, barium chloride. If you're not sure how to write a formula, just think of barium as an ion, chlorine as an ion. They swap the charges, so it's barium chloride 2. So we need 2 chlorines for every barium ion. So barium chloride, and we know it's aqueous, plus solution containing sulfate ions. So solution tells us it's aqueous as well. SO4 2 minus, as this is the formula for sulfate. And this gives us sulfate displaces chlorine, so we get barium sulfate as a precipitate. And then what we've got left is chlorine ions. But we had 2 chlorines there, so to balance it out, we've got to have 2 chlorines on the other side as well. The next thing what we do is we look at all the aqueous elements and we can write them out as ions. So barium ion plus 2 chlorine ions plus sulfate ion gives us barium sulfate. This is a solid, so we can't split it into ions, and 2 chlorine ions. If you're not sure how I'm getting here, just visit the blog and go through all the steps first and then come back and do the questions with me. So we have to look for spectator ions now. Spectator ions are the ones that are not involved in the reaction. So it's chlorine in this instance because it's exactly the same on either sides. So we only got barium 2 plus sulfate, which gives us barium sulfate solid. As you can see, chlorine was aqueous on either side, so the ions will just flow in and all the barium ions were stuck together with sulfate ions giving us the precipitate, and then the chlorine ions were just left alone without anything happening to them. So this is the final ionic equation. It wasn't that hard to get there, but practice makes it perfect. Okay, so we've got another question. Write an ionic equation including state symbols for the reaction between hydrochloric acid and magnesium to form aqueous magnesium chloride and hydrogen. So they exactly tell you what will form, what was involved. So we've got hydrochloric acid, aqueous, and magnesium. It's a ribbon, so it's a solid, which gives us magnesium chloride. And it says it's aqueous. If you're not sure how to get magnesium chloride like this, you look at the ions. Magnesium 2 plus, chlorine minus, so they change powers, giving us magnesium chloride. 2 chlorides for each magnesium ion. So what we also get is hydrogen. And hydrogen is a gas and it always goes in pairs. So we've got 2 hydrogens on this side, 2 hydrogens on this side. Got 2 chlorines and 2 chlorines, 1 magnesium and 1 magnesium. So the equation is perfectly balanced. Now all the aqueous. We've got hydrochloric acid as in aqueous state, but we've got 2 of each, so 2 hydrogen plus 2 chlorine minus, plus our magnesium as a solid, which gives us magnesium 2 plus aqueous plus 2 chlorine minus aqueous plus H2. It's a gas, so no ions. Next thing we have to do is look for the spectator ions. It's chlorine again. And now we can work out our two half equations. Two H pluses give us hydrogen gas. So to balance it out, we have to add 2 electrons. Our next half equation is magnesium solid, giving us magnesium 2 plus ions plus 2 electron minus to balance it out. So two half equations show us the two parts of a redox equation. So we've got hydrogen with plus 1 charge, and it goes to hydrogen. So it has an oxidation number of 1 in here, and has an oxidation number of 0 on this side. So it gained electrons. So this is reduction. On this side, magnesium has an oxidation number of 0 on this side and plus 2 on this side. So it's oxidation on this side. Now we just combine these two half equations into one ionic equation. So we've got 2H plus is aqueous plus 2 electron minus plus magnesium solid, working out to be hydrogen gas plus magnesium 2 plus aqueous plus 2 electron minus. As we can see, we've got 2 electron minuses on either side, so we can just cancel it out and write our final ionic equation. And that's it. This is the finished equation. And now a very last question. When aqueous solution of calcium hydroxide is added to an aqueous solution of sodium carbonate, a white precipitate of calcium carbonate is seen. Write an ionic equation for this reaction, including state symbols. So what we already know is that a solution of calcium hydroxide, so aqueous, so calcium as a 2 plus, OH minus is the hydroxide ion. They change this powers to give us calcium hydroxide. 2 hydroxides for every calcium. So calcium hydroxide, and this is aqueous, plus aqueous solution of sodium carbonate, NaCO3. If you're not sure how I got there, you can, Na2, sorry. You can also do it this way. So sodium has a plus, carbonate has a 2 minus, change the powers, Na2CO3, and it's aqueous again. And this gives us a white precipitate of calcium carbonate. This means it's a solid. And what we've got left is 2 H's and 2 sodiums. So NaOH, we've got 2 of them. And this is aqueous. What we've got to do now is split the aqueous parts into ions. So calcium 2 plus 2 OH minus plus, I've made a mistake here as well because it's solid, no splitting into ions. Just be careful with this. So now we just got to cancel out the spectator ions. 2 OHs and NAs. And now what we've got left is Ca2 plus aqueous combining with CO3 2 minus to give us the white precipitate of calcium carbonate. And that's it. Finished equation. If you would like a copy of all of these questions I've been through, just visit my blog and email me, or just leave a comment and I will contact you and send you the question. If after all of this you think you're not ready for the questions yet, find the link attached with my tutoring down in the description. And also please remember, everything I show you are my techniques and ways of learning and revising. If you have any question about my videos, please comment or email me. I leave the link in the description down below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Now like, subscribe and see you soon. Bye.